Sum series and integral calculus. Sum series and integral calculus into which we are pursuing the discussion. Can we can we convert a discrete function into continuous function? That is the heart of this solution. The approach that has not been seen in the book. Can we convert a discrete function into continuous function? Okay, there are many advantages to it. One advantage is the problems which are in discrete domain, they can be transferred into continuous domain. And then a problem is transferred into continuous domain, then it can be tackled through calculus. That is the number one. Number two, a problem which has nothing to do with the calculus, a problem which has nothing to do with the calculus, it can be transformed into calculus, because once it comes into arena of calculus, once it comes into the grammar of calculus, then after that life is easy. Life is easy in a way that it can be computed through the big bunch of formulas, ready-made formulas available in calculus. What I'm trying to say is, if continuous graph is like a sinusoidal, then we can calculate the area. If continuous graph is like a logarithmic, if continuous graph is like x square, if continuous graph is like e to the power x, a to the power x, then we can calculate the area. But anyway, at the end, as I have said, that kite will fly only. The kite as a bird, you cannot imagine that kite is running for you. Kite is not a horse. The horse which runs on the ground and it does not fly. You cannot imagine that a horse will fly for you. And similar way, you cannot imagine that kite will run for you. And you cannot imagine the whale fish, though it is a mammal, still whale fish will fly for you or whale fish will run for you. Okay, you cannot imagine your elephant will swim inside the ocean, not possible. Everything is meant for itself only. One particular use anyone is meant for. If you want to solve mathematics, only human can do. You cannot imagine your dog that he will sit and he'll solve your calculus problem. Anyway, but human cannot run. I believe maximum 40 kilometers per hour or something a human can run or something. But it has no comparison with the cheetah and these kind of animal who run at 100 kilometers per hour. And that too, one or two human can only run at 40 kilometers per hour. Otherwise, not even 20 kilometers per hour a human can run. Okay, so it is not that possible also. But cheetah can run 100 kilometers, 120 kilometers per hour. So human, as the name is in Sanskrit called Manusya. Manus means person who does manan. Manan means who thinks. And that's how human is. Human is known for its mental ability. Otherwise, there is nothing in human that surpasses any other animal. Human cannot swim inside the water. Human cannot fly. Human cannot run. Human cannot do anything. It can think that no other animal can do. So everyone has its own speciality, and no one is complete now. No one is complete. Everyone is specialized in one environment. Everyone. Okay, in that manner, the integral calculus is specialized. If you give an algebraic equation to integral calculus, then it will calculate area underneath it. If if the algebraic equation is sin x, then if sin x is a graph, underneath integration sin x dx from x1 to x2, where on x-axis x1 and x2, it will calculate the area underneath. This is what it would do. This is what it would do, maximum. Okay, what is minimum? This is the minimum. And what is maximum? This is the maximum. If someone calculates anti-integral, though this word is not used, anti-derivative is used. If someone is going for anti-integral, then if someone has a graph, then he will get slope of the graph. At any point, what is dy by dx? Okay, if this is the graph, whoop, 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 okay, if this is the graph and this is x-axis and this is the graph, What is integration? Integration will calculate underneath along the x-axis what is the area from x1 to x2 or any x1 to x2, this area strip it will give. What is differentiation? If this is the graph, that at any moment it will give dy by dx. Sir, I understood. Boss, I understood. Area concept. What is at any moment it will give d. This is what is written in the book. You read any book, it will written that for any graph, differentiation will calculate dy by dx at that point. For any graph, integration will calculate that fx dx. What is this? What is that? That no one knows. What is dy by dx at this point? If this is x-axis and this is y-axis, then I say if I calculate differentiation at this point where this is x and this is function over x, height is function over x, and this distance is x, or this is y and this is x. At this point, what is dy by dx? Differentiation will calculate dy by dx at this point. What is dy by dx at this point? No one knows. Okay. Is it y by x? No. This is not y by x. If I have a curve like this, sine curve, and this is origin, and this is x-axis, and this is y-axis, if I take any point x here, then this is the y. Dy by dx, is it y by x? No, this is not y by x. Then what it is? I can imagine, either I can say that here, from if this is x, then if this is x, then x go and hit here. I can imagine one area underneath it, or I can imagine if this is y and this is x, then this is y by x. What is third thing? What dy by dx done? Dy by dx done is, what is this? This is a point. What is this? This is a line. Is it a straight line? No, this is not a straight line. This is a curved line. Okay. Every moment it is a curved line. Not, that is not true. Every moment it is a straight line. It is not a curved line. Every moment it is a straight line. Altogether it is a curved line. That is true. But every moment it is a straight line. How you prove it? Every moment it is a straight line. Take the example of moon. From far it looks like a complete sphere football. Complete a football. If someone lands on the moon, then he will say, who said moon is football? Moon is completely flat. Okay, I can measure with whatever measurement you do, but it is completely flat. It is not football. Means if you go near to it at a particular point, this is called local linearity, then it will behave like a straight line. What I'm trying to say, make a liquid flow through a pipe and which is in sin x curve. A liquid is flowing through this pipe. Every moment, liquid is passing through a straight line. Every moment. But that is different thing. That point to point direction is changing. But at a particular point, direction is exactly straight. Then at other point, direction is exactly straight. But those two straight are not same. Point to point straight line is different. Okay, that is vector. If I take vector at so many points, how many points? Okay, I have 2 points. I have a distance, very small distance. In between, how many points I have to take? Infinite points. Means infinite point. If I take every moment, the line will be straight, and then it will differ. Okay, when line is straight at any point, consider at this point there is a straight line. That is also called a tangent line. So consider at this moment, consider if you see the curve at this moment, the direction of the liquid is flowing like this. Then at this moment, direction of liquid is exactly like this. That is, we can call tangent. At that moment, line is straight. Take out that line. This line is at that moment, take out that line. And this is the line. Okay. And then draw a straight line. If this is the line, at that moment, take the line in which take any point here and take out the line that is actually representing the curved line. Take out that line outside. Make it pass through origin. If this is the line, then bring it down so that it will pass through origin. Now, for this line, everywhere y by x will be same. Everywhere. That y by x is dy by dx. Okay, every moment if I have a straight line, that straight line, if I make it pass through origin, then what is y by x at any moment? Everywhere on a straight line, y by x will be same. That is dy by dx. Okay. If I take another point, let it infinitesimally small distance from this point to this point, then line will differ. So every moment you are saying dy by dx is different? Yes, certainly. Every moment dy by dx is different. What about straight line? Then every moment dy by dx will be same, because tangent line to a straight line is a straight line itself. Anyway, these are the basic concept of calculus. And if I want summation and series, then we have to go through the we have to go. If I want summation of a series, what series we are taking? If for a summation of series, we have taken alternate series. Alternate series means if I alternate series what we have taken, it is written in examination is 1 plus 4 plus 3 plus 6 plus 5 plus 8 plus 7 plus 10 plus 9 plus 12 and so up to 124. Not 124 terms are there. Last number is 124. Calculate the summation. This is what is written in examination. Calculate the summation. To calculate the summation, we have now in examination it is written 1, 4, 3, 5, 6, 7. Therefore, 1, 4, 3, 3, 6, 5, 8, 7, 10, 9, 12, and so on. A person who is very avid, now he would be looking that there are two series hidden here, because no one can find. If someone want to find the summation, he has to find the algebraic equation for it. That no one can find algebraic equation for any term. What is algebraic equation? If it is 1, 2, 3, 4, 5, 6, 7, 8, then algebraic equation for any term is just x. What is x? Consider this is x-axis. When x equal to 1, then I have a value called 1. That is function over x or y. Function over x or y is 1. X equal to 2, y is 2. X equal to 3, y is 3. And so on. When x equal to n, y is n. Means I can say at any moment x equal to x, the vertical is x. Because the series is 1, 2, 3, 4, 5, 6. Means at position number 1, number is 1. Position number 2, number is 2. Position number 3, number is 3. But we see this series, that is 1, 1, 4, 3, 6. And then we have 5 and 8 and so on. If I do like this, if I see like this, then we have two series hidden here. One is 1, 3, 5, 7, 9, 11, and another is 4, 6, 8, 10, 12. There are two hidden series. They are combined together. At position number 1, we have 1. At position number 2, we have 4. At position number 3, we have 3. At position number 4, we have 6. At position number 5, we have 5. At position number 6, we have 8 and so on. So anyone would say there are two series hidden here. One series, if I take, then x equal to 1, 3, 5, 7, and function over x or number at those positions is 1, 3, 5, 7 again. Another series is x equal to 2, 4, 6, 8 and so on. When x equal to 2, number is 4, the number is 6, the number is 8. So when x is 6, number is 8 and so on. Two series are hidden here. How to calculate this series? We have to add it separately. This is a very corner case. We have to add it separately. And if I add it separately, we have to calculate the summation. Now consider the last term is 124. This is what is written in examination. 1 plus 4 plus 3 plus 6 plus 5 plus 8 plus 7 plus 10 plus 9 plus 12 and so on up to 124. Okay, I don't know how many terms are there, but the vertical, if I take it, vertical is 1, 4, 3, 6, 5, 8 and so on. Okay, first we will calculate for the odd number x. 1357. If this is the x1357, function over x is again 1357. If x is 2468, function over x is 46 plus 2. Anyway, we have done two times already. We will do third time and then we will calculate again for the inverse of it. Inverse of it is 1 by 1 plus 1 by 4 plus 1 by 5 plus 1 by 6. Consider in examination it is written like this: 1 by 1 plus 1 by 4 plus 1 by 3 plus 1 by 5 plus 1 by 6 plus 1 by 7 plus 1 by 8 plus up 1 by 1 plus 1 by 4 plus 1 by 3 plus 1 by 6 plus 1 by 5 plus 1 by 8 plus 1 by 7 plus 1 by 10 and so on. Infinite, because they will tend to 0 only. So infinite. Can you calculate it? This is what written exam. We will tackle it. We will solve the first one through third way, that is the central area. Central area means if I have, okay, I have dissociated my problem, segregated problem into two parts. First is odd indexing. Odd indexing is x equal to 1, 3, 5, 7, 9. This is called odd indexing. Even indexing is x equal to 2, 4, 6, 8 and like so. Function over x is 1, 3, 5, 7. Function over x is 4, 6, 8, 10 plus 2. So if I try to calculate the odd number, then we have summation x equal to 1 to x equal to n function over x, where function over x is x1. When x equal to 1, it is 1. X equal to 3, it is 3. When x equal to 5, it is 5 and so on. Okay, what about for even number? Summation x equal to 2 to x equal to n, where n is even number. There n was odd number. Function over x, where function over x is x plus 2. When x is 2, function over x is 4, then 6, then 8 and so on. These two we have to add it. Okay, if I talk about only odd number on x-axis only odd number indexing. In that manner, if I have x equal to 1, then I have fx as 1, x equal to 3, I have fx as 3, x equal to 5, I have fx as 5 and so on. If I connect all the top point of this fx, it will lead to a straight line. Hope, where is a straight line? Okay, it will lead to a straight line like this, where fx is x. If I talk about even number slots, then it will start from 4 and fx is x plus 2. So first we will calculate the odd number summation. Now if this is, now okay, anyway, now if when x is 1, x is 3, let's tackle the odd number first. X is 1, x is 3, x is 5, x is 7 and so on. Then we have value as 1, 3, 5, 7. But we are seeing there is a gap of 2 between two sampling. Function over x is a discrete function and it is sampled at x equal to 1, 3, 5, 7 and so on. This is also called point mass function. Points mass function, it is vertical line only. If I see minutely, then between x equal to 1 and x equal to 3, there is a gap and there is nothing here. Okay, means I can take an area strip like this and it will go like this and that will hit a continuous function called gx. What is gx? I don't know. This I have to find. But there is an area strip from x equal to 1 to 3, it goes and hit gx. This area strip means against each vertical line, I have an area strip on right hand side of width 2, because there is a gap of 2. The last is x equal to n, then n to n plus 2, there is an area strip like this, gx. Gx means this area strip will have area at gx dx summation x equal to 1, x equal to n plus 2. Limit n to n plus 2 is the area strip that correspond to vertical at x equal to n. Area strip from x equal to 1 to 3, that will correspond to vertical at x equal to 1. So as many verticals are there, so that many area strips are there. Makes sense? Means summation x equal to 1 to x equal to n fx dx equal to limit x equal to 1 to 3 f gx dx 3 to 5 gx dx plus n to n plus 2 gx dx. For each fx, I have one area strip on right hand side. This we have seen. Then we have seen left side also. If this is x equal to 1, then left side area strip of width 2. Then width 2. Last will be from n minus 2 to n. We will take central one now. Central one means if I have x equal to 1 function over x, then from x minus 1, 1 minus 1 to 1 plus 1. Okay, again width of 2. We have to take width of 2. So width of 2 area strip around 1, around 3. Okay, means this area strip will again touch each other from 0 to 1, then 1 to 3, 1 to 4, x equal to 1 and 3, minus 1 plus 1, x equal to 1 to 2, x equal to 0 to 2, one area strip, 2 to 4, one area strip, 4 to 6, one area strip, where in between verticals are there at x equal to 1, x equal to 3, x equal to 5, x equal to 7, and so on. This is the central area strip. If I have x equal to 1 function over x, around it I have one area strip. Then at x equal to 3, around it one we have area strip, where all area strip, they are contiguous and non-overlapping. That is the concept. So that if I have so many verticals from left to right, then area strip will cover complete area from left to right. Make sense? Means if I say at any x equal to x, then I have a function over x. At x equal to x, I have a function over x, and that is x. So function over x at x equal to x will be same as x minus 1 to x plus 1 gx dx. X minus 1 to x plus 1 gx dx, that is equal to function over x at x equal to 1. At x equal to x, function over x will be integration x minus 1 to x plus 1 gx dx. We have to find gx. Okay, now fx equal to gx dx. Gx is dfxy by dx. X means 1. We'll start gx with 1. 1 dx will be x. X minus 1 to x plus 1 will come as 2. We are getting 2 where required is 1. We'll multiply by x by 2. We started with 1. We'll start with x by 2. X square by 4. Limit x minus 1 to x plus 1. X square, that will become x plus 1 whole square minus x minus 1 whole square. In that manner, x square and 1 will go away. 2x and 2x will remain. It will come as 4x. 4x by 4. Exactly, it is x only. Amazingly. If people are watching our previous video, then we were in trouble actually when we were setting the limit x to x plus 2 or x minus 2 to x. When we set limit x minus 1 to x plus 1, it is coming exactly at 4x by 4, that is x. So we had taken gx as x by 2. Solved. If gx is x by 2, then limit x minus 1 to x plus 1, actually it comes as x only. What I am trying to say is, if I have a continuous function gx, and if I calculate the area of the gx from x equal to 1 to x equal to 0 to 2 plus 2 to 4 plus 4 to 6 plus 6 to 8 plus and so on up to n minus 1 to n plus 1. So for each vertical, I have an area around it. Okay, if x equal to, means I am trying to say is our gx function is x by 2. Means if I integrate x by 2 dx, limit from 0 to 2, it will give exactly as 1. Anyone can try. X by 2 integration is x square by 4. 0 to 2, it will come as 4 by 4, 1, 1. You mean that if I try x equal to 2 to 4, then in between x equal to 3 is there, where function over x is 3. It will come as 3. Yeah. 2 to 4, x by 2, x square by 4, limit is 2 to 4. 16 minus 4, that is 12 by 4, 3 only. Someone can try next one, that is x equal to 0 around 5. 5 around 5 means 4 to 6. 4 to 6 will come as 5 only. Someone can try x by 2, that will be x square by 4. Limit is 4 to 6. 36 minus 16 by 4, that will come as 20 by 4, 5 only. Amazing. This is what means each sub area from left and side. Sub area with gx will be same as in between vertical as fx. Very nice. So everything we have found now. What is summation of all the vertical? This is what we want. Limit x equal to 1 to x equal to n fx, where fx is 1. This is what we want. Then that will be same as summation of all the sub area around the vertical. Yeah. The leftmost limit is 0 and rightmost limit is n plus 1. 0 to n plus 1 x by 2 dx will give the net summation of 1357. Okay, if that is the case, then how much it will come? It will come as x square by 2, 0 to n plus 1, n plus 1 by 2 whole square, x square by 4, x square by 4, n plus 2 n plus 1 whole square by 4, n plus 1 by 2 whole square by whole square. This is what we had got earlier also. It is perfect. What about the even number summation? Same way we will do for even number slots. X equal to 2, 4, 6, 8. When x equal to 2, function over x is 4. 6 means x plus 2. So fx equal to x plus 2 equal to gx dx. Dx is dfx by dx 1. We'll start with 1. 1 dx, that is x minus 1. Same thing because gap is 2. X minus 1 to x plus 1 2. Just 2. Here we want x plus 2. We are getting 2. We'll try adding x and try again. Okay. We started with 1. So x plus 1 we will try. Okay, x plus 1. This is not the perfect way. Perfect way is settle down the order by order. So I think we'll try that way. So we want x plus 2 and we are getting 2. 2 into x to the power 0, where required is x to the power 1. Means we have to start with x because x is the main thing. So rather than starting with 1, we will start with x. Okay, x dx, x square by 2. That will be x minus 1 to x plus 1. That will come as 4x by 2. 4x by 2 will come as 2x. Here it is x plus 2. Here we are getting 2x. Means we will start with x by 2. X by 2 will come as x. We have already seen it. It will come as x. This side wanted is x plus 4. So x plus 2 and we are getting x. When we took fx as x by 2. When we took fx as x by 2. Okay. If I take fx as x, then it comes as x square by 2. That will come as 4x by 2. It will come as 2x. Makes sense? We'll try again. Dx as x, then x square by 2. Limit x minus 1 to x plus 1. It will come at 2x plus 2x. 4x by 2. 2x. Wanted is x. We are getting 2x. Means wanted is x and we are getting 2x. We have to divide by 2. We will start with x by 2. X square by 4. 4x by 4. X. Here we are getting x plus 2. Here we are getting x. We had started with x by 2. We will add 2 now. So it becomes x by 2 plus 2. We try. X square by 4. X minus 1 to x plus 1. X plus 1 whole square minus x minus 1 whole square. Everything will go away. 4x will remain. 4x by 4, that is x. Plus 2. 2 integration will be 2x. X minus 1 to x plus 1. 2. 2 into 2, 4. But we want 2. So we will try again with x by 2 plus 1. So that is successive approximation. X square by 2. We are doing this much example so that it will be crystal clear to everyone. X square by 4, that will come as x plus 1. 1x x minus 1 to x plus 1, 2. So we have got the gx, and gx is x by 2 plus 1. What do you mean? I mean in x equal to 2, x equal to 4, x equal to 6. At x equal to 6, I have a function over x as 8. Means x equal to 6. If I integrate from 5 to 7, then it should come as 8. Yeah. Okay. Limit 5 to 7, x by 2 plus 1 dx, x square by 4 plus x, where limit is 5 to 7. 49 minus 25, that will come as 24 by 4, that will come as 6, plus 1x, x is 5 to 7, that is 2. 6 plus 2 is 8, 1. Amazing, mind blowing. So we have got the solution now. For the odd number series, we have n plus 1 by 2 whole square, plus for even number series. Okay, we did not calculate the even number series. For even number series, x equal to 2 is the minimum. So we'll start from minus 1, that is 1. And last, if n is even number, then n plus 1, 1 to n plus 1. Earlier we had tried 0 to n plus 1. Here it is 1 to n plus 1. X by 2 plus 1. X by 2 is gx. X by 2 plus 1 is gx. X by 2 plus 1 dx. 1 to n plus 1. It will come as x square by 4 plus x. X square by 4 plus x. 1 to n plus 1. Okay, in that manner it will come as n plus 1 whole square by 4. X by 2, x square by 4. X square limit will be n plus 1 whole square minus 1. Makes sense? Plus 1x, 1, and in bracket n plus 1 minus 1. That is n. Here n plus 1 whole square minus 1. N square plus 2n by 4. N square plus 2n by 4 plus n plus just n. That will come as n square plus 2n plus 4n by 4. N square plus 6n by 4. This is what exactly we saw in the last sessions also, in the previous sessions also. Okay, so previous term we saw n square plus 6n by 4. Now for the odd number, we have n plus 1 by 2 whole square, n plus 1 by 2 whole square, plus n square plus 6n by 4. Okay, means one side we have n square plus 2n plus 1 by 4. One side we have n square plus 6n by 4. Okay, if that is the case, then how we will proceed now? This side n is odd number. This side n is even number. In examination, it is written up to 124. Means last x is 122. Then it is 124 plus 1, even number. So even number n is the reference, not the odd number n is the reference. So odd number will be 1 less than that. So n plus 1 whole square will become n minus 1 plus 1 whole square, where n is referenced in the even number. That will become n square by 4 plus n square plus 6n by 4, 2n square plus 6n by 4, where n is 122. If last number is 124, then x will be 2 less 122. Means 2 into 122 whole square plus 6 into 122 by 4 is the solution. Okay, someone would ask, can you try up to 4, up to 6? Up to 6 means 1 plus 4 plus 3 plus 6. Okay, if that is the case, then n is 4. 1, 2, 3, 4. N is 4. Then it will be 2n square. This is what we are saying. 2n square. 4 into 4, 16 into 2, 32. 32 plus 6 into n. That will come as 24. So 32, 30, 32 into 32 into 20, 32 plus 24. That will come as 56. 56 by 4. How much it will come? 56 by 4. Is it really divisible? Okay. I don't think so. 14. 14. 14 is the answer. Let's try. 1 plus 4 is 5. 5 plus 3 is 8. 8 plus 6 is 14 only. Amazingly mind-blowing. This is how it is. Now can someone take it as an assignment to calculate the inverse of it? Inverse of it is 1 by 1 plus 1 by 4 plus 1 by 3 plus 1 by 6 plus 1 by 5 plus 1 by 8 plus 1 by 7 plus 1 by 10 and so on. Just I inverted it and then calculate for infinite. Again, we will take odd number slots and even number slot. In odd number slot, it is 1 by 1, 1 by 3, 1 by 5, 1 by 7. In even number slot, it is 1 by 4, 1 by 6, 1 by 8, 1 by 10, and so on. Can someone calculate addition of this? This is amazing mind. Why we have taken this example? There is no concept of even and odd. In examination earlier it was 1 plus 4 plus 3 plus 6 plus 5 plus 8 plus 7 plus 10 and so on up to 124. Consider it is written in examination it is 120, it is 123 up to 123. Then last x is 123 means odd number. If it is odd number, then n will be odd number. So n plus 1 whole square by 4. N plus 1 whole square by 4. This n in odd is the reference now. If that is the case, then n is in even number. N in even number will be 1 less than that because even number last is less than that. Even number is n square plus 6n by 4. Then n will be replaced by n minus 1 whole square plus 6n minus 1 by 4. Someone can try that out. But when we are taking inverted one and it is going for infinity, both n will be same. That's why I am taking this example. Both n will be same. It will be similar to Grandi series. Grandi series, where both n will be same. Okay, if both n will be same, then what will be the answer? That we will see. Mind-blowing, amazing, not available in any of the book. We will see many more things. In Fibonacci series, we calculated the summation of series. Okay, we did not bring a perfect result. We went through a big result and thought this is the end. I was seeing some book in Fibonacci series. The addition of Fibonacci series is fx equal to fx minus 1 plus fx plus fx equal to fx minus 1 plus fx minus 2. This is Fibonacci series, where summation of all series up to x equal to n is fn plus 2 minus 1 or something like that. Very straightforward. That we will see we can get through integral calculus or not. That summation of Fibonacci series from x equal to 1 to x equal to n is indeed it is fn plus 2 minus 1 or not. That also we will corroborate and see. These are not available in any of the book. Anyone can try. Please don't mind supporting us. +91 is the India country code. 9483160610 is the telephone. +91 is the India country code. 9483160610 is the telephone.